Hello, and today we're going to do the chapter 4-2 quiz review because we had two quizzes this chapter. So this is over sections 4-4, 4-5, and 4-6. This first one says factor the polynomial completely. Look out for missing terms. So whenever I have that, I need to check and make sure I have everything here. I see that I have a degree of 3, so I should most likely end up with 3 parentheses at the end. You don't have to, but you should. So the first thing I would often do here is I would graph it, and I would synthetically divide to break it down. So looking here, I need to pick one x-intercept. For the sake of argument, let's say we're going to use x equals 3. 3 is going to go in my synthetic division box, and I can look at my polynomial, my coefficients. Am I skipping any levels? Nope. So I'm going to get 1, -5, -9, and 45. Then from there, drop the 1. 3 times 1 is 3. -5 plus 3 gives us -2. 3 times -2 is -6. -9 plus -6 gives us -15. 3 times -15 is -45. 45 plus -45 is 0. It's important to note that through the remainder theorem and the idea of direct substitution ideas, if I'm using an x-intercept, I should always get 0 for a remainder. That tells me it's a factor from the factor theorem, and also that the y value would be 0. Well, conceptually speaking, looking at the graph, for an x-intercept, the y value is always 0. So if I get a 0, I'm all good. If you did not get a 0 for the remainder, one of two things happened. Either you graphed incorrectly and picked a wrong x-intercept, or you synthetically divided incorrectly. So double check both your work there. Anyway, so that's my remainder, which makes my -15 my constant, my -2 my x, and 1 x squared. So I get x squared minus 2x minus 15. Remember from Lilo and Stitch, Ohana means family. Got to bring that with me. And it's always opposite, so that's x minus 3. And then now I'm down to a quadratic. I got a factor. So what multiplies to -15 that adds to -2? Well, that would be -5 and +3. Now, this problem does just say factor. It does not say solve. So I can actually stop right there. If I were to solve and set those equal to 0, I would get +3, +5, and -3. All of those are real solutions, and they're also all on my x-intercepts. And again, it makes sense because my degree was 3, so I should get 3 answers at the end anyway. Over here, same idea. I'm going to graph it, pick one x-intercept. Looks like I'm going to pick x equals 6. Now, I'm actually missing x squared. So remember, we have to put in a 0 for x squared. So I'm going to get 1, 0, -28, -48. Everything else stays the same. Drop the 1. 6 times 1 is 6. 0 plus 6 is 6. 6 times 6 is 36. -28 plus 36 is +8. 6 times 8 is 48. Done with that. X squared plus 6x plus 8. Bring down that. Flip it. So x minus 6. What multiplies to 8? Adds to 6. Well, again, I can always use my graph to cheat a little bit. Looks like it's going to be -2 and -4, so it'd be opposite. So x plus 2, x plus 4. On the next one. Now this one equals 0 and says find the zeros. So we're going to go one step further and actually solve these. So not just factor, but set them equal to 0 at the end. So, but the nice thing is I would start the exact same way. I need to pick one intercept and synthetically divide with it. So for the sake of argument, I'm going to pick -3. And I'm not skipping any levels, so I can just write the numbers as they are. Negative 3 times 1 is negative 3. Add those together, we're going to get negative 9. Negative 3 times negative 9 is positive 27. Negative 27 plus 27 is positive 20. Negative 60, 0. So I get x squared minus 9x plus 20. Bring this negative 3 down, flip the sign, so x plus 3. And I can factor what multiplies to 20 adds to negative 9. That would be negative 4 and negative 5, excuse me. And then, of course, I have to set each of those equal to 0. So we get negative 3, positive 4, and positive 5. Again, those are three real solutions that all appeared on the x-axis right there, so it should be good. I had a degree of 3, so I should only end up with 3 answers. This next one also has a degree of 3, but we see we only have one x-intercept, which tells us that the other two solutions are most likely going to be imaginary. So let's be ready for that. Well, let's put negative 3 in our synthetic division box. Looking at my polynomial, I'm not skipping any levels. So drop the 1. Negative 3 times 1, negative 3. 3 minus 3 is 0. Negative 3 times 0, 0. 4 plus 0 is 4. Negative 3 times 4 is negative 12. So I get x squared plus 4. Bring down the negative 3 in reverse. And we can start setting things equal to 0. As we showed earlier, this is going to be that negative 3 right there. Now, this must generate our imaginary solutions. If I had a trinomial, three things like this guy over here, I would try to factor it. But because I know they're imaginary, I know it wouldn't factor. So I might have to use the quadratic formula. Here, because I only have x squared and 4, I can just set this thing equal to 0. And I can solve it traditionally. So minus 4 minus 4. Square root, square root. Now we are square rooting, which means we get the plus and minus. Also, it's a negative 4, so we can treat that as the square root of 4 and the square root of negative 1. Recall the square root of 4 can be done, that's just 2. And anytime we're square rooting a negative, in this case negative 1, that turns into an I, which makes sense because we know we're supposed to have imaginary solutions here. So those would be my three solutions there because 2i and negative 2i are two separate things. Last one, we are given the zeros and running a polynomial function, so we are going backwards. So we know that x equals negative 3, x equals 1, and x equals 2. So we have to turn those into parentheses. So x plus 3, x minus 1, and x minus 2. Importantly, it tells me my leading coefficient is 1, so I can stick a 1 out front. But from here, I need to just FOIL and condense this a little bit. So x times x is x squared. X times negative 1, negative x. 3 times x, 3x. 3 times negative 1, negative 3. Combine like terms, x squared plus 2x minus 3. And then I can multiply it times this binomial over here. So x squared times x, x cubed, x squared times negative 2, negative 2x squared, 2x times x, positive 2x squared, 2x times negative 2, negative 4x, negative 3 times x, negative 3x, negative 3 times negative 2, positive 6. And that's just a matter of combine like terms. So we're going to get x cubed. Our x squareds are going to cancel out, so I'm not going to put anything there. Negative 4x minus 3x, that's negative 7x, and then plus 6 at the end. Okay. Thank you for listening, and I hope you have a great day.